Okay, so now we're going to talk about computability to a greater extent. And I just want to make it very clear that we're going to talk about the halting problem and the decision problem, which is very difficult to understand. And I'm not going to test you on the halting problem, but it's sort of an in-depth lesson about it. So try to keep up, but it's not the end of the world if you can't, okay? So, what is computability? Imagine that somebody tells you that every even natural number greater than 2 is the sum of two prime numbers. So you test this up to 10, right? So you go, okay, 4 is an even number. That can be the sum of two prime numbers, 2 plus 2. 6 is another even natural number, which can be the sum of two prime numbers. 8 can be the sum of two prime numbers, and also 10 can be the sum of two prime numbers. Okay, so cool. You've tested it up to 10. But how do you know this is true for all possible even numbers? And we could ask a computer, but the program would never stop computing. And this statement about prime numbers, yeah, so this statement about prime numbers is actually called Goldbach's conjecture, and it's never been formally proven to be true or false. And there are many problems that we have proofs for that somebody proved to be true or false. But some of these problems we didn't have proofs for at one time, but do now. And even today, there are problems that we still don't have proofs for. This is one of them. So we could keep working at trying to prove these problems, but it's possible that some of the problems are uncomputable or undecidable, meaning that they can never be proved or solved. And this gets to the core issue of computability. What is computable and what is not computable? Yeah, so what can be computed? What are the limitations of computation? Um, what are the limitations of computation? What can be computed and what functions can be solved by an exact algorithm or steps in a way that guarantees a correct solution? What problems can in principle be solved and what problems are answerable? What kinds of problems can computers or people solve and what is possible to know? So mathematicians and logicians, so logic, people who do logic, they wanted to know whether there was a formal method to figuring out whether a problem could be solved or proved or not. And so this is actually called the decision problem, but I'm going to step back and talk about the halting problem. Alan Turing basically reframed the decision problem in terms of the halting problem. So imagine you wrote so here it is, right? Imagine you wrote a program that is very inefficient, and you know that it'll take at least 12 hours to finish, even if there are no bugs in your code. And if anybody's ever programmed, I have, and I'm not very efficient at it. I'm a psychologist, so I'm not good at programming, and computer scientists are way better than I am. So maybe I'll program something and it'll take a while, and then the next morning I'll wake up and I'll see it still running. And the question is, did I do something wrong, right? Uh, so you leave it overnight and check it in the morning, it's still running. And maybe while looking over the code, you start looking over the code. And because you started doubting yourself, right? And so you realize that the reason it's still running is because indeed there is a bug in your code and you did do something wrong. Um, so while this problem that you're trying to solve, you tell the computer to solve the problem or to search for a solution, right? So here is like a sort of like pseudo code, right? It's not really computer code, but it's the idea is that, while this problem is not solved, basically what I'm telling the computer here is while the problem is not solved, keep searching for the problem or the solution, right? Um, And so let's say, hey, so you're basically saying, hey, computer, while you haven't solved the problem, keep trying to solve it, right? But maybe the problem isn't solvable, is the idea. Maybe this will continue to run forever. And so the question is, will it ever halt? So is there a way way for a program or a method to decide whether it will be successfully executed or not. And that's the halting problem, whether it will halt or not. So if you're given a program in some formal language, is there a method that will tell us whether the program will halt or not? So if a program halts, it's been successfully executed. If a problem is not solved, then the program it's not solvable, then the program would run forever. And the halting problem is how do we figure out whether it will halt or not? And again, this is a reframing of the decision problem that is related to two of David Hilbert's 23 unresolved problems or challenges for mathematicians to solve. I'm not going to test you on that, but as a side note. Um, and so, yeah, to get back to Alan Turing, some of Alan Turing's contributions, one thing he did is he clarified the notion of a formal method via algorithms and computation. He also developed an idealized model of a computing machine, which is known as the Turing machine. And then he also showed that the decision halting problem was actually not solvable. So there is no way to tell whether something is solvable or not. There are just some problems that are simply not computable, and there's no way to tell. But in doing so, but in doing this, he by showing that the halting problem was not solvable, he also came up with this hypothetical machine that will find a solution, and that's called the universal Turing machine. Okay, and so we'll talk about the Turing machine in the next video.